Welcome to another episode of Terry's Notes, and today we are going to be looking at the sine rule and cosine rule. Now, in an earlier video that we did, we focused on determining lengths and angles in a triangle, but a triangle that is right angled. So what we're going to look at is two rules which will allow us to solve for angles and lengths of triangles that are not right angle triangles. So the first thing we're going to do is, let's say we have a triangle like this, and the sides are the vertices are A, B and C. Alright, so this is angle A, this is angle B, and this is angle C, and none of them are 90 degrees. What that means is that this length here will be B. This length will be A, and this length will be C. Right? Now this is what the sine rule says. It says that A over sine A is equal to B over sine B, which is equal to small c over big sine C. Now, when students see an equation looking like this, they get confused, and it can be very confusing because if you notice, there are two equal signs, and this poses a challenge to some students. So what the equation is really saying is that we can say that A over sine A is equal to B over sine B. We can also say that B over sine B is equal to C over sine big C. We can also say that A over sine A is equal to C over sine C. Don't get too confused with this, right? What you need to remember, it's the length of one side divided by the sine of the angle that is opposite to the length is equal to another side divided by the sine of that angle which is opposite. Okay? So I'll show you an example as to how we can use the sine rule. So let's say we have a triangle that, now these triangles are not drawn to scale, okay? Just a quick sketch. So we have 40 degrees, we have 60 degrees, we have this length which is 8 centimeters, and in the question we are asked to find x. Right? Now there are no right angles here, so we cannot apply sine, cosine or tangent, those ratios. So what we're going to use in this case here, we have this 60 degrees and we have the side that is opposite, which is x. We have 40 degrees and we have the side that is opposite, which is 8 cm. So we're going to apply the sine rule. So what you do, you set up the sine rule first. So sine A over sine A is equal to B over sine B, and we're going to put A as, use A as x over sine 60 degrees is equal to 8 over sine 40 degrees. Okay? Now you can work out the sine of the angles initially, or you can just do it like this. You cross multiply at this point. Actually, you know what? Let's work out the angles, the sine of the angles. So let's say sine 60. Sine 60 is 0.866, which is equal to 8 over sine 40. Sine 40, which is equal to 0.643. Now we're going to cross multiply. So 0.643 3x is equal to 8 multiplied by 0.866, and therefore x is equal to 8 by 0.866 all over 0.643, and this will be equal to, let's say, 8 multiplied by 0.866 divided by 0.643, and this gives me 10.8 centimeters. Okay, now let's do another example, in which case we want to find an angle this time using the sine rule. So let me give you a triangle here. So this angle is 120 degrees. This is 9.2 centimeters. This is 6 centimeters, and we want to find this angle theta. Alright, so first thing we do is set up the sine rule, which is a over sine A is equal to b over sine b. So let's say we use let's use A as 6, and the angle that is opposite would be sine, this is sine theta, is equal to b, which is 9.2 all over sine 120 degrees. Okay, so you could decide what you want as A or B. Alright, just be consistent. Okay, so 6 divided by sine theta is equal to 9.2 over sine 120, and sine 120 is equal to 0.866. Okay, so at this point what we do, we cross multiply. So we say 9.2 sine theta is equal to 0.866 multiplied by 6. Therefore sine theta is equal to 0.866 times 6 over 9.2. So sine theta is equal to 0.866 multiplied by 6 divided by 9.2, and we get 0.565, and therefore theta is equal to sine inverse 0.565. Therefore theta is equal to 34.4 degrees. So you get 34.4 degrees. Alright, so these are two examples that show you how to use the sine rule. Let's look at the cosine rule now. So in the case of the cosine rule, if we have a triangle, and the triangle is A, B, C, therefore we know that this length will be small c, this length will be small a, and this length will be small b. The cosine rule says that a squared is equal to b squared plus c squared minus 2bc cos e. Alright, And we could also have different variations of this depending on the angle, but you just need to remember one of them and apply it depending on what the case is. And I believe they give you these equations in the exam either way. Alright, so let me do an example. Alright, so let's say we have a triangle like this, and we have, this is 100 degrees, and this is 8 cm, and this is 6 cm, and we want to find the length x. So find x. Alright, so when do we use the cosine rule? Use the cosine rule when you have the three sides of a triangle and we are asked to find an angle, or if we have an angle and we have the two sides on either side of the angle. In this case here we have 100 degrees and we have 8 cm on one side and 6 cm on one side. So we can use the cosine rule here. So the first thing we do, we set up the cosine rule and we say that a squared is equal to b squared plus c squared minus 2bc cos a. Alright, and the a in this case is always the side opposite the angle that we have. So this will be x squared is equal to b. You could choose either the 8 or the 6 as b, doesn't matter. 8 squared plus 6 squared minus 2. Put this in our big brackets because this is where students have some problems. 2 multiplied by 8 multiplied by 6 multiplied by cos the angle, which is 100 degrees. So therefore x squared is equal to 8864 plus 36 minus, we're going to use the calculator now. So this will be 2 multiplied by 8 multiplied by 6 multiplied by cos 100, and this gives us minus 16. So this will be minus 16.67. So therefore x squared is equal to 64 plus 36 plus 16.67, and that will give me 116.67, and therefore x is equal to square root of 116.67, and therefore x is equal to 10.8 cm. Okay, so let's just double check this here. 2 multiplied by 8 multiplied by 6 multiplied by cos 100, that gives me minus 16 point, right, so this is, it is 64 plus 36 plus 16.67 second function. Okay, so 10.8 cm, right? Whenever you have long calculations like this, you should always double check to see if there's an error. Right, now let's do another example where we have a triangle, and this is 8 cm, this is 6 cm, and this is, let's say, 10 cm, and we are asked to find this angle theta. How do we do that? Alright, so we have all three sides of the triangle and we are asked to find an angle, so therefore we use the cosine rule for sure. So we're going to set up the cosine rule. So a squared is equal to b squared plus c squared minus 2bc cos a. And the small a, we usually take that to be the side opposite the angle we are interested in. So this will be 6 squared is equal to 8 squared plus 10 squared minus 2 multiplied by 8 by 10 by cos theta. Right, so 6 6 is a 36, 8 8 is a 64, 10 10s 100 minus, so this is 2 by 8 by 10, 8 is a 16 by 10 is 160, so this is minus 160 cos theta. So what we should do is carry across the cos theta on the other side, so we end up with 160 cos theta is equal to 64 plus 100 minus 36. So therefore 160 cos theta is equal to 64 plus 100 minus 36, and that gives me 128. Therefore cos theta is equal to 128 over 160. Therefore cos theta is equal to, divided by 160, that gives me 0.8. Therefore theta is equal to cos inverse of 0.8, and therefore theta is equal to second function cos, which gives me 36.9 degrees. 6.9 degrees. Okay, so as you can see, we can use the cosine rule when we have three sides and we are asked to find an angle, or we can use the cosine rule when we have two sides and the angle between them. Okay, so once the triangle is not a right angle triangle, we have to use either the sine rule or the cosine rule in order to solve for angles and lengths. Okay.